All right, so you should have just added these new rules into your notes. As you take a look at these, one thing that will help you to work with these and help you to remember them is actually, I want you to notice here that it's actually the exact same rule. Just one of them has been simplified for you. Because the second one, ln of x, remember natural log of x is just log base e of x, which means that if I use the rule above it, writing it like that, it would be 1 over x times the natural log of e, and of course the natural log of e is 1. So that's why the natural log is just 1 over x. So it's actually the same rule. So if you just remember this one, then you can remember both. It's just that if you remember this one, it comes up so often, it's going to save you some time along the way. All right, now, of course, since we got a new rule, I want to see how we can use and apply these. So we're going to be doing a number of problems here together on them. Go ahead and write down that first one, and then we'll walk through that, and then we'll go through the second as well. All right, so for the first one here, y equals log base 10 of 2 plus sine of x. One thing I want to point out to you, though, and remind you of, is that that would be exactly the same as if I had just written log of 2 plus sine of x. Because remember that log means log base 10. Just trying to write the 10 in there to really bring home on this first example why we do what we do. All right, so I'm going to be figuring out what is y prime here. Yes, we're finding derivatives for each of these. And so notice I have the log function of another function. So I have a function within a function, which means chain rule here. And so the very first thing I'm going to do is the derivative of the outer. So that's going to be 1 over. Now remember, wherever it shows x in that rule, it means whatever's inside of log. So in this case, that's going to be the whole 2 plus sine x. And then that's times the natural log of a. A is our base. Therefore, it's times the natural log of 10. That is the derivative of the outer function, the derivative of log base 10. Now I have to multiply that by the derivative of the inner function, which is 2 plus sine x. Well, the derivative of 2 is 0, so that's gone. Derivative of sine of x is cosine of x. And really, there's not too much else we need to do here. I tend to like to actually clean up my fraction a little bit. I'd put the cosine of x on the top. And, you know, personally, I like to write natural log of 10 because it's technically a constant first and then go 2 plus sine x. But, you know, that doesn't really matter. So if you left on the bottom the parentheses 2 plus sine x, then wrote the natural log of 10, that's perfectly fine. Do we need to do anything else here? No. If we actually knew what x was, we could plug it in and we could do calculations and we could actually calculate the natural log of 10. Of course, that's going to be a decimal. But until we actually have to get a number out, leave it in the exact form, which means leave it in terms of natural log of 10. So now let's do the second one, the one on the right there. The one on the right's natural log, which is actually good news because natural log is actually slightly simpler to deal with, as you can tell by our derivative function. So I'm going to go to y prime here. And y prime, because it's natural log, again, it's chain rule. There's an inner function inside of the natural log. So it's going to be 1 over whatever is inside of my natural log. So that's 1 over x squared plus 1. But because we are using chain rule, I multiply that by the derivative of the inside. That's x squared plus 1. Derivative of x squared is 2x. Derivative of 1 is 0. And so it's all times 2x. And again, clean that up. I don't want to leave it as a fraction times 2x. Let's actually just call it 2x over x squared plus 1. Does that simplify or reduce at all? No. And that's an idea that I really want to bring home because still every now and then I'll see somebody who's like, oh, I got an x on top and an x on bottom that I can cancel out. No, we can't because there's not an x in the one term. It would have to be able to come out of every single term, and so we've got to leave it just like that. All right, now for these, well, things can start getting interesting, of course. All right, so for this first one, We're going to go y prime equals. I'm finding the derivative of log base 7 of something. Specifically, it's log base 7 of the e to the x. When you're writing these problems out and doing them, if it helps you to focus on what the inner function is by adding those parentheses, even though the original problem didn't have it, by all means do so. It'll help you to visualize and see it. So I'm going to do 1 over, x is whatever was inside of it, so that's going to be the e to the x, times the natural log of the base, which is 7. Now, because it wasn't log base 7 of x, it was log base 7 of e to the x, I now need to multiply that by the derivative of e to the x, the inner function, which is e to the x. Now, when I go to clean this up, normally I'd just say, okay, throw that on the top and call it good. But you notice what that does in this particular case. Can this one simplify? Yes, because this e to the x and this e to the x are in the only 2 terms in the whole fraction. There are no other terms that we would have to take it out of. So the whole thing just simplifies down to be 1 over the natural log of 7. It's a constant. All right, and now on the second function, y prime equals, notice we got sine within the natural log. So we're against chain rule, 1 over whatever was inside, so that's sine of x, times the derivative of that inside, so the derivative of sine is cosine. And so that ends up equaling cosine of x over sine of x, which we can actually tidy up even just a little bit further. What does cosine over sine equal? What's it equal? Cotangent. I heard a few tangents in there. Tangent sine over cosine. Cosine over sine is the cotangent. All right, so when finding the derivative of that first one there, we end up doing log base 2, so that means 1 over whatever's inside, times the natural log of 2, times the derivative of that inner function right here. And then just tidy it up a little bit. And that's your final answer. All right, now on to the second problem then. So on this one, when we go to find y prime, we're going to do natural log. So 1 over whatever was inside of it. So that's going to be the cube root of 6x plus 7. Then that's going to be times the derivative of the cube root of 6x plus 7. Now, let's remind ourselves how to deal with the cube root. Remember that cube root is the same as taking my 6x plus 7 and doing it to the power of 1/3. That's what cube root, of course, means. So if I'm going to find the derivative of that, notice it's actually chain rule again. So in order to do this problem, we're really using chain rule within chain rule. Because I have to do the derivative of the outer function, that is something to the 1/3. So that's power rule, 1/3, 6x plus 7, and then subtract 1 from 1/3 gives me negative 2/3. And then I multiply that by the derivative of the inner function. Derivative of 6x plus 7 is just 6. And so when I go and figure that out in my problem here, that's exactly what I'm putting in. That's how I got that value. Now for the fun part. This simplifies. Because I'm going to take my y prime equals, so I know I have a big fraction here, and it's a matter of putting the right stuff in the right places. So in my fraction, I know I'm going to have the cube root in the bottom, so the cube root of the 6x plus 7, that's just carrying over from that first part. But it's not just going to be a 1 on the top. We're going to be putting something else up there, as you'll see in a moment. The 1/3 that I encounter next, that means that I have a 3 on the bottom. The 6x plus 7 to the negative 2/3. Remember that a negative exponent means that it is also in the bottom. And so then I have 6x plus 7 to the power of 2/3. And then the 6, well, that's just a whole number, so that part gets to go on top. Okay, so certainly this is a lot cleaner. But actually it goes even cleaner than that. Significantly so. Now, by the way, this simplification I'm doing right here, this is more of that gravy. This is more of that pushing you to see a little bit more kind of stuff. Not necessarily what you're going to see on a regular basis that you're going to have to do quickly and easily at this point. Although the more you see these, the easier your life will be later, as you'll see. Because this one actually simplifies down quite a bit. So we get y prime equals. Notice the 6 on top and the 3 on bottom. I can actually reduce those down so it's actually just a 2 on the top. And then on the bottom, notice I have the cube root of 6x plus 7 times 6x plus 7 to the 2/3. Now the 2/3 means that it is the cube root of 6x plus 7 squared. But notice they're both cube roots. I can put them together and it ends up being 6x plus 7 cubed and cube root, which means it all just equals 6x plus 7. So the whole thing actually works out to just be 2 over 6x plus 7. All right, so for this last one here, we're finding the derivative. Okay, fine, it's got a natural log in it, fine. But notice it has both x and y there. So it is going to have to be derived implicitly. So let's go ahead and go through our implicit differentiation here. So 3y. You know, the funny thing is, after doing so many of these, something like 3y is actually the one that tends to give us trouble. A lot of people want to say that it's 3y y prime, but it's not. It's 3y prime. Because notice it's just a constant times y, so my derivative will be the constant times the derivative of y. When we end up saying that it's 3y y prime, we're thinking of like when it's y to a power. All right, then minus. Then we do the derivative of x squared, which is 2x, plus the derivative of y natural log x. What rule am I going to have to use here? Product rule. Because this is actually y times the natural log of x. Product rule still sneaks up on some of us, right? So let's use our product rule. So that means derivative of the first, so that's y prime, times the original second, so that's just the natural log of x, plus the original of the first part, which is y, times the derivative of the second. So the derivative of natural log of x now, so that's going to be y times 1 over x, equals the derivative of 2, which is 0. We've now done the derivative implicitly. If you want to clean it up before taking your next steps, you certainly are welcome to. Oftentimes it makes the next step easier to see. There's not a lot of cleanup to do, but certainly by turning this y times 1 over x into y over x, it just might make it a little bit more comfortable for you to do. But go ahead and now solve that for y prime. All right, and so this is where we end up as a final answer here when we solved it all out for y prime. Yes, we could simplify this. You could multiply everything on top and bottom by x to get that fraction out of the fraction and a few little things like that. But right now, this is the main priority. You at least need to be able to get it to there.